Welcome to week 5 of the Fundamentals of Chemistry lab. This week our lab activities focus on the factors that can affect rates of chemical reactions and that can shift equilibrium in reversible reactions. The objectives of this week's lab are to determine the effect of concentration, temperature, and the addition of a catalyst on reaction rate, to extrapolate the rate law from experimental data, to understand what equilibrium of a chemical reaction means, to explore Le Chatelier's principle, to determine the influence of a common ion on an equilibrium reaction, and to determine the effect of temperature and concentration on an equilibrium reaction. Before we move on to this week's material, let's take some time to recap Module 4. In our lab activity in Module 4, we used calorimetry to determine the enthalpy of a chemical reaction. Enthalpy is the total heat content of a chemical system, and a change in enthalpy is equal to the change in heat and the change in volume under constant pressure. Calorimetry enables us to measure the magnitude and direction of heat transfer. When a calorimeter is used, the pressure and volume remain constant. Therefore, the change in enthalpy is equal to the change in heat. The change in heat of a reaction is determined by knowing the mass and specific heat of the compound, as well as the change in temperature. An exothermic reaction releases heat, while an endothermic reaction absorbs heat. In Module 4, we explored the enthalpy of a chemical reaction. This week, we are focusing on continuing to explore chemical reactions and factors impacting those reactions. The collision theory is the theory on how chemical reactions occur. Chemical reactions occur when particles collide with enough force to achieve the activation energy for the reaction to proceed. The activation energy is the minimum amount of energy required to break the bonds in the reactants, after which new bonds can be formed to produce the end products of the reaction. Not only do particles need to collide with enough energy, but the particles must also collide with a proper orientation for the new bonds to form. There are 4 factors that can impact the rate at which a reaction proceeds: temperature, concentration, the addition of a catalyst, and physical state of the compound. The first factor that can affect reaction rate is temperature. As temperature increases, so does the rate of the chemical reaction. Increasing temperature increases the velocity of particles. This increased velocity results in more collisions. As the velocity of particles increases, so does the kinetic energy, resulting in a greater fraction of collisions having enough energy to meet or exceed the activation energy. Concentration is another factor that can affect the rate of a reaction. An increase in concentration of a reactant increases the reaction rate. A greater concentration of reactants results in a greater number of collisions. Introducing a catalyst to a chemical reaction also increases the reaction rate. A catalyst provides an alternative pathway for the reaction to occur that lowers the activation energy. This way, more collisions have the energy needed for the reaction to proceed. The physical state can impact reaction rate because the state a chemical is in can determine how much surface area is available to react. Reactions between molecules in different states have slower reaction rates. Reactions between molecules in the same state have faster reaction rates. It's important to note solids have less surface area, so reactions with solids move more slowly. The rate law is used to determine the rate of the reaction. The rate of a reaction is determined by the reaction rate constant and the concentration of each reactant to the power of its reaction order. The reaction order is the proportional influence each reactant has on the reaction rate. Lab Activity 5-1, Factors Affecting Reaction Rate, has 5 activities this week. You will explore how concentration, temperature, and the addition of a catalyst affects reaction rate, and you will experimentally determine the rate law for a reaction. The second part of this week's lab focuses on reactions and equilibrium. Chemical reactions can be reversible or irreversible. At the beginning of a reversible reaction, only reactants are present, so only the forward reaction occurs. However, as the reversible reaction continues and products are formed, the backward reaction begins. Over time, a dynamic equilibrium is reached where the rate of the forward and backward reactions are the same. So both reactions continue to occur, but there is no change in the concentration of the reactants or products. If a stress is placed on a reversible reaction at equilibrium, the reaction will shift to counteract the stress. Therefore, the equilibrium will shift. This is known as Le Chatelier's principle. Notice in the table that changes in concentration of a reactant or products and temperature will result in a counteracting shift. We will explore Le Chatelier's principle in Lab 5-2 this week, Equilibrium and Le Chatelier's principle. There are 4 activities that will allow you to see these principles in action. If you have any questions on this week's lab, please post to the General Questions discussion board or email me at t.foster@snhu.edu. I am here to help you successfully complete this course.